Okay, greetings. Hope everyone had a good break. Uh, anyway, my phone. Anyway, phone's vibrating. Get distracted here. Let's get back to what I want to talk about. Remember, we're applying transformations. Let's talk about a couple topics here. Remember, we talked about increasing. As I go left to right, increasing or decreasing functions. This function here is as I go as x gets bigger, y gets smaller. So all the way from -6, notice this function is continuing to decrease all the way to here. So from -6 to 2, this function is decreasing. And then it increases as I go left to right. As x gets bigger, y gets bigger from here to here. So from 2 to about 5, it's increasing. And then from 5 to 6, it's decreasing again. So we talked about increasing and decreasing functions. Let's talk about relative or local maximum or min. So to have a relative or local min or max, you have to have a change in slope or go from a change in increase or decrease. So I'm decreasing, 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 and right here at this point I change to increasing, or my slope goes from negative to positive. So here's a relative min at x equals 2. The coordinates would be 2, -4. I've got a relative max at 5, 2, because I'm going increasing to decreasing, okay? Relative min, relative max, or local min and max. Now absolute can be in endpoints. Remember, relative or local max or mins cannot be endpoints because you don't have the change in direction. My absolute max is here. Occurs at -6. It's got a y value of 5. My absolute min is also my local min. You can be both, a local and absolute. Occurs at 2, -4. Okay? Concavity. Okay? Concave up is where I've got a smile. Concave down is a frown. That change in concavity is an inflection point. So right here at -3, I have an inflection point. Smile, frown. And right here at 0, it goes from a frown to a smile. And this whole thing from 0 to 4, this is all smile. And then at 4, another inflection point, we go from a smile to a frown. Okay? The zeros, the x-intercepts are at 0, 4, and 6. X equals 0, 4, and 6 is where my x-intercepts or my zeros are. Okay? The x values that give you a y of 0. Anywhere on the x-axis, your x-intercepts have a y of 0. Okay? All right. Let's talk about, notice, I'm going to go through this main point here of f of x, and then we'll do these transformations, okay? All right. So here's function of f of x, all right? Let's just take one point. This will be doing Tuesday. My absolute min is at point 2, -4. Here's the ordered pair 2, -4. That's the x and y value, all right? There's my transformation. Remember, anything outside the parentheses is something vertical. Okay? Inside is going to be horizontal. Inside the parentheses, okay? So basically, I'm not affecting my input at all. I'm just affecting the output. Okay? So this is going to be a vertical stretch. This is basically, x isn't affected. I plug in x, I spit it out, and I get an output. So here's this point, 2, -4. What's going to happen to this point when I do 2 times f of x? Well, x isn't affected. X stays 2, but we're just multiplying the output. So all of a sudden, my -4 doubles to -8. So it's basically x, comma, 2 times my y value. So this point here would be stretched down to -8. It's a vertical stretch. Here is 1/2 times my output. F of x is synonymous with y. Okay? So 2, -4, again, my x is 2. It's the output of -4, we're going to multiply by 1/2. And now that this ordered pair goes from 2, -4 to 2, -2. It's basically x, comma, my ordered pair is be x, comma, 1/2 times y. Anytime you're multiplying by f of x, it's just changing your output. Okay? So this point here would get compressed. It's a vertical compression to about right here. Okay? All right. Now notice my 2 and 1/2 are inside the parentheses, okay? So this point, my absolute min of 2, -4, is now, it's going to be horizontally squished into 1, -4. Notice I'm not changing my y. okay, my absolute minimum occurs when 2 is stuck in the function machine. But notice, to put 2 in the function machine, I only need half the x. Okay, normally it's 2 gives me -4, but now I only need to put in a 1 to create that -4, because if I put in 1, I'll multiply it by 2 first, and then 2 goes in and creates -4. So by multiplying by 2, I need half the x value. I hope you guys all understand that. X is 1, I multiply it by 2, and I produce that -4 just like here. But this basically is 2 times the 1 gives me the 2, which creates the -4. Okay, so my absolute min occurs at 1 now. This is a horizontal compression. This graph is gonna occur right here now at 1. Okay. By the same token, inside the parentheses is horizontal. This will be a horizontal stretch. For me to create this 2, I need double the x value because I'm going to have it first. I'm going to plug in 4, and half of 4 is 2, which creates -4. Okay, so that's a horizontal stretch. Think about my original value. What created -4, 2? I need to put the x in that's eventually going to go in that function machine. If it's 1/2 x, 1/2 of 4 is 2, which creates -4. This is getting stretched out, so this point is going to get stretched over here now, okay? All right, inside parentheses, horizontal. This is just going to be plus or minus is a shift, not a stretch. Multiplication division is a stretch, all right? So I got an absolute min at 2, -4. Well, now it's going to go right 3. It's going to occur at 5, -4. This is going to shift over. The whole graph shifts. It's not a stretch or compression. This whole graph shifts to the right, and this point will be at 5, -4. Okay? Because we all know that 2 creates -4. Well, 5 minus 3 is 2 and gives me the -4. So this whole graph is a horizontal shift. All right, now we're outside the parentheses. That's vertical. Inside is horizontal, outside. This is basically the y. Okay, so notice my x doesn't change. It's still 2 from the original 2, -4. But I take this -4 and I add 2 to it. Okay, that's my y. -4 plus 2 is -2. Okay, this is changing the sign of my output, my y. So notice, instead of being 2, -4, my 2 is still the same, and I get -4. And then after we plug out the -4, what do? I change the sign. Okay, so basically this is x comma -y. This just changed my y value from -4 to +4. This is basically what? This flips your graph over the x-axis, okay? This will flip up here, and this flips down here. This will be flipped over the x-axis, okay? So I'll have a relative max here now with this, all right? Okay? Here, remember, this flips your whole graph about the y-axis, okay? So right now, I've got an absolute min at 2, -4. This min is going to be flipped over, and it's going to occur at -2, okay? So my new absolute min and a relative min as well will be at -2, -4, okay? My x changed, okay? All right, I'm going to plug in a -2, and the opposite of -2 is 2, which creates a -4. So this point flips over, and it'll be at -2, -4. This flips it over the y-axis. This changes your x. This changes your y. All right. We've talked about this. This makes sure that everything, absolute value of my input, is what? Everything is positive. I lose. This whole graph goes away. And this graph here now is reflected over here. So it's in 2 places. It's over here and on the left of the y-axis. Because every input is positive now. So I have no negative inputs. I cannot create this graph. So I have an absolute min now in 2 places. Here at 2, -4, 2, -4. But also this is reflected. This graph is going to come down here. This whole graph here is reflected, and it appears over here as well. This shows up in 2 places. So I'll also have this coming down, and I'll have an absolute min at 2, -4 and -2, -4. Like I said, this ensures that this is the only graph that's there because all my inputs are positive. So these turn in, so this graph stays here and is reflected here. I've got this graph coming down. I've got this point appears here as well. So I've got two absolute mins and relative mins at 2, -4 and -2, -4. This makes sure that every output, every y value is positive, okay? So notice, anything that's negative reflects over. Anything that's positive doesn't change. The absolute value of these positive values doesn't change. Anything below the x-axis is now reflected up. So the min value I could possibly have on this graph is going to be these zeros, okay? So now, as this graph flips up here, this 0, this 0, and this 0 are my three relative mins and absolute mins. Notice I've got absolute mins now at 0, 0, 4, 0, and 6, 0, where my zeros are, okay? All right? This reflects anything that's below the x-axis that's negative becomes positive, y values. This makes sure all my inputs are positive, which will get rid of anything to the left of the y-axis and reflects anything over, okay? So I think hopefully everyone can understand that. This has been 11 minutes, so this will be a good precursor. Hopefully you all read this, okay? Or hopefully you all see this video. I'll see you Tuesday. Look forward to seeing everybody, okay?